In this lecture, we find the nth derivative of the function y is equal to cos x, cos 2x, and into cos 3x. We have given that y is equal to cos x into cos 2x into cos 3x. Now, we know that nth derivative of cos ax plus b is equal to a to the power n cos ax plus b plus n pi by 2. This is the nth derivative of cos ax plus b. But in the given example, there is a cos x multiplied 3 times cos x multiplied by cos 2x multiplied by cos 3x. So is it possible to convert this product of 3 cos function into the form of addition or subtraction? If we are able to do that, then it is very simple to find the nth derivative of the given function. For that purpose, let us do some operations. We can write y is equal to, we are multiplying and dividing by 2. So 1 upon 2 into 2 cos x cos 3x into cos 2x. Now cos 2 cos x, 2 cos a cos b. We apply the formula for that. We know that cos a plus b is equal to cos a cos b minus sin a sin b. Similarly, cos a minus b is equal to cos a cos b plus sin a sin b. If we add them, we get this 2 will cancel. This is minus and this is plus. Therefore, this 2 will cancel. And this is cos A, cos B, cos A, cos B. So 1 plus 1, 2 cos A, cos B, which is equal to cos A plus B plus cos A minus B. 2 cos A, cos B, which is equal to cos A plus B plus cos A minus B. Here we have 2 cos x, cos 3x. In place of A, it is x. In place of B, we have 3x. Hence, from 2, we have y is equal to 1 upon 2 cos A cos B. 2 cos A cos B, which is equal to cos x plus 3x plus cos x minus 3x into cos 2x. Cos x plus 3x is cos 4x and cos x minus 2x is minus cos minus 2x. One upon 2 cos 4x, cos minus 2x, cos 2x. But we know that cos of minus theta is cos theta. Cos 4x plus cos 2x, because cos of minus 2x is cos 2x, into cos 2x. Now if we open the bracket, 1 upon 2 cos 4x into cos 2x plus cos 2x into cos 2x. Now we again multiply by 2 and divide by 2. 1 upon 2 into 1 upon 2, and this is 2 cos 4x cos 2x plus 2 cos 2x cos 2x. Since 2 cos A cos B is equal to cos A plus B plus cos A minus B. If we apply that formula, this formula, then it will become cos 2x plus 4x plus cos 4x minus 2x, and in the second part, cos 2x plus 2x and cos 2x minus 2x. Cos 4x plus 2x is cos 6x. Cos 4x minus 2x is cos 2x. Cos 2x plus 2x is cos 4x. And cos 2x minus 2x is cos 0. Let us again simplify it. Cos 0 is equal to 1. So we have written in the first term. Then cos 2x, this cos 2x, cos 4x, and cos 6x. Therefore, y is equal to 1 upon 4, 1 plus cos 2x, cos 4x plus cos 6x. Now differentiating n times by using the formula what we have discussed in the earlier of the question, nth derivative of cos ax is equal to a to the power n cos ax plus b n pi by 2. And now we consider that here n is more than 2. Then we have nth derivative of y, which is equal to 1 by 4. We can take outside. Nth derivative of 1 is equal to 0. Nth derivative of cos 2x is 2 to the power n cos, because a is equal to 2 over here. And a is equal to 2 to the power n cos 2x plus n pi by 2. This is the nth derivative of cos 2x. Similarly, nth derivative of cos 4x is 4 to the power n cos 4x plus n pi by 2. And nth derivative of cos 6x is equal to 6 to the power n cos 6x plus n pi by 2. If we again simplify it, then nth derivative of cos x, cos 2x, cos 3x, which is equal to 1 upon 4, 2 to the power n cos 2x plus n pi by 2, plus 4 to the power n cos 4x plus n pi by 2, plus 6 to the power n cos 6x plus n pi by 2. This is our desired nth derivative of the given function. Thank you.